Friends, welcome to my YouTube channel. Dhanesh here. Another interesting session on machine learning. The last video we were discussing about chi-square test, ANOVA test, one-way ANOVA we discussed, two-way ANOVA we discussed, practical examples of ANOVA we discussed. In this video, I am going to discuss about F-test. This is a quote from Socrates, and an examined life is not worth living. Let's continue. F-test, it's also known as F-statistics. F-test is named after the great British statistician R.A. Fisher. That's why this F-test. F-test is used to find out whether the two independent estimates of population variance differ significantly. Fine, this is easy. This is the mathematical formula behind F-test. F is equal to sigma 1 square divided by sigma 2 square. You know sigma is the standard deviation of the population, and the S is the standard deviation for the sample. The S is for standard deviation of the sample, and sigma is the standard deviation for the population. This standard deviation gives the spread of data, it gives the scattering of data. You already know we have videos for standard deviation and variance in the playlist statistics. You can watch those videos. So sigma is the standard deviation, and sigma square is the variance. You need to understand the square, sigma square is known as the variance. The square of the standard deviation, where it's known as variance. We have videos for variance and standard deviation. You can watch it. So you understood. And one more point you need to understand here is sigma 1 square should always be greater than sigma 2 square. Sorry, like this. And S1 square should always be greater than S2 square. So this is the math of F-test. Sigma 1 is the standard deviation, and S1 is the standard deviation for the sample. Okay, fine. Now another thing, see here I have explained the sigma 1 square variance, and sigma is the standard deviation. The formula for this variance, you are familiar with this. This is for population, it is sigma x minus mu the whole square by n. N is the number of samples, and this is S square. This is for the sample, this is for the population. This is x minus x bar the whole square by n minus 1. This is for the sample, and this is for the population. You can understand what's the difference between population and sample. We have videos for population and sample in the playlist. This is the simplest equation you can understand. F is math of F test like this. You can understand larger estimate of variance divided by smaller estimate of variance. In short, we can summarize the formula in this way. This F statistics is also known as an F value. It's a random variable that has an F distribution. See, the F statistics follows F distribution. You need to understand. But our t-test, ANOVA test, z-test all follows normal distribution or Gaussian distribution or bell curve. See, our z-test, t-test, and ANOVA, these all follow normal distribution or Gaussian distribution or bell curve. But F test or F statistics follows F distribution. I have a separate video on F distribution. You can watch it. It's a random variable. That let us consider now. We are considering a random sample of size n1 from a normal population having a standard deviation equal to sigma 1, and consider an independent random sample of n2 from a normal population having a standard deviation equal to sigma 2. This is the summary. Sigma 1, I am giving the mathematics of F test in terms of chi-square statistics. That's what I am going to tell you. See, for that, let us assume that Sigma 1 is the standard deviation of population 1. S1 is the standard deviation of the sample drawn from population 1. Sigma 2 is the standard deviation of population 2. S2 the standard deviation of the sample drawn from population 2. Chi-square, it is the chi-square statics for sample drawn from population 1. V1 or nu 1, sometimes you use the Greek letter nu as well. Nu 1 is the degree of freedom for, the chi-square statistics. Psi 2 square, this is the, chi 2 square is the statistics for the sample drawn from population 2. This is the degree of freedom for the second chi square, right? So this is degree of freedom, it is n1 minus 1, it is nu 1, and nu 2 it is n2 minus 1. So if these are all the data we have, so degree of freedom, you need to understand degree of freedom, p value, then significance level, these are all important terms. We have separate videos, please watch it. Then this F statistics can be written as, see, we have this equation S1 square by sigma 1 square, the whole divided by S2 square by sigma 2 square. This is the equation for F for two population. So then we can rewrite it as psi 1 square divided by v1, the whole divided by psi 2 square by nu 2 or v2. Here we have taken as v2. V1 is the degree of freedom and v2 is the degree of freedom for the second sample. Psi 1 square, this is the chi-square statistics. Psi 2 square, it's a chi-square statistics for the second sample. This is another important equation you can remember for the F statistic. F statistics and null hypothesis. Calculated F value is less than the tabulated. If calculated F value is less than the tabulated F value, null hypothesis is accepted and no significant difference between the two variances. Calculated F value is greater than tabulated F value, null hypothesis is rejected and there is significant difference between the two variances. F test is the ratio of two variants, hence it is also known as variance ratio test. Is another point. See, this is the way we will accept and reject null hypothesis. Tabulated F value means you will get it from the table, F distribution table. You can get the F distribution table from the net. We will compare normally for all the tests. We will compare the statistics from the the F value, the calculated value. We will compare with the from the table we are getting the F distribution table, we will get on F value. But we will compare that and based on that only we will reject the null hypothesis and accept the null hypothesis. You know that. Fine. So that's all about the F statistics. Thanks for watching. Please like, share and subscribe. Thanks a lot.